Alright, quiz 5 solutions. Let's see, number 1, part A, find all critical points of f. Here's f, critical points happen when the derivative equals 0, or when the derivative is undefined, but in this case we won't run into that problem. So logical first step, let's find the derivative. Let's see, the derivative of negative x cubed is negative 3x squared plus 6x plus 9 plus 0. So here's our derivative right here. Critical points come when this thing equals 0. We got to solve this guy. There's a few ways to solve it. I think the easiest would be to factor out a negative 3. And we get something like this. Factor out a negative 3, you get x squared minus 2x minus 3. And then this factors out, we need two numbers that multiply to negative 3, add to negative 2. So let's see, negative 3 and positive 1. I think we'll do the trick. And once you have it in this form, we have something times something equals 0. Negative 3 never equals 0. This will equal 0 when x equals positive 3. This will equal 0 when x equals negative 1. So these right here are the critical points of f. Alright, part B, we have to use those critical points, determine whether they're a relative maximum, relative minimum, or neither. I think the best way to do that is to use the second derivative. Let's see, we know the first derivative is, let's leave it in this form. If we take another derivative there, we got negative 6x plus 6. So the question is f double prime of 3 greater than 0 or less than 0? Let's see, this is negative 18 plus 6, which is negative 12. Although really you don't even need to know what this value is. All you need to know is that this is less than 0. And we can also figure out the second derivative at negative 1. Same idea, stick in negative 1 in here. This would be 6, this would be 6, so we get 12, which is greater than 0. So because the second derivative at 3 is less than 0, we have this shape, if you will, the sad face, which means that 3 is a relative max. And over here, the second derivative is positive, so it has the happy face shape, which means that it's a relative min. So I guess that's it. I guess that's our answer to part B. See if I can draw a box around it. And we'll move on to number 2. Number 2, here's a function. Find all intervals on which this function is decreasing. Alright, decreasing means the first derivative is less than 0. Okay, let's find the first derivative. What do we got here? It looks like a product rule, huh? This times this. So the derivative of x is 1, leave e to the 2x alone, and then add to that, leave x alone, and take the derivative of e to the 2x. We got a chain rule going on there. Ends up being 2e to the 2x. The outside function is e to the x, the inside function is 2x. So you get this right here. We want to figure out when this is decreasing. It might not be a bad idea to factor out an e to the 2x before we start that. So if I guess we're simplifying the derivative here. Take out an e to the 2x and you're left with 1 plus, looks like 2x over here. And so it's decreasing when e to the 2x times 1 plus 2x is less than 0. Okay, so we need to figure out what x's make this true. E to the 2x is always positive. E is a positive number. Any positive number raised up to an exponent will always be positive. So really, the derivative is positive when 1 plus 2x or sorry, the derivative is negative, since this is always positive, when this is negative. So when 1 plus 2x is less than 0, which we can solve by subtracting 1 from both sides, and we get x is less than negative 1/2, which I guess is fine how it is, or if you put it into web work terms, it would look more like this. Really, either one's fine. Maybe I'll put the box around this guy. Make sense? Moving on to part B. Find all intervals on which g is concave up. Okay, so we're going to have to take a second derivative, right? It's concave up when the second derivative is greater than 0. First derivative, let's use this guy right here. So we want to take the derivative of this guy. Looks like we got a product rule again. The derivative of e to the 2x, we already saw this, is 2e to the 2x, chain rule going on there. And then leave this guy alone. So what I'm figuring out here is g double prime of x. And then to this we have to add, leave the first guy alone, and multiply this by the derivative of the second guy, which is just 2. We could probably simplify this a little bit. Let's see, both terms have an e to the 2x in it, so we can pull out, we could pull out 2e to the 2x, I guess, since they both have a 2e to the 2x in them. Really, either way is fine. And what that leaves you with is 1 plus 2x plus 1, right? 1 plus 2x, and then there's just a plus 1 left over here. So that is equal to 2e to the 2x times 2x plus 2. So to figure out when it's concave up, we want to know when 2e to the 2x times 2x plus 2 is greater than 0. Again, this guy is always positive, right? 2 times a positive thing, we already decided this is positive, is always positive. So this times this is positive if 2x plus 2 is greater than 0. Subtract 2 from both sides, divide by 2, and we get when x is greater than negative 1. So I guess to be consistent, I'll put this into interval notation too, even though I didn't specifically ask you to, so I don't really care whether you did it or not. And we'll call this the answer. And that is the end of quiz 5.